on Android, iOS, and desktop. And while we are doing this, you can see here several of our games. And the first one that I created, that I fully created on my own, was this one. And when I was doing this, I was asked to use a bunch of libraries that we already had for creating games. And so what I did is I took a look at these libraries, and then it got really, really hard. So I couldn't understand what these libraries are doing. I didn't know. They were not documented in a good way. They were signature. They were abstract. Great. That's cool. But it's hard to understand. So I was sitting there. OK, yeah, this module, if you combine it with this other library, with this function, then you get something out of it. But it's really hard to understand it. I'm a remote worker, which means if I have a question, I need to ask other people via email, or I need to wait to the next meeting. And this is something, you can't work like this. So many times I just thought, oh, come on, can I create it on my own? Can I just create my own function that I know how it works? And then, yeah, it's cool for me. But what happens then? I have this library, which is already doing cool stuff. I'm creating another library who is more or less doing the same. And then we need to maintain both of them. And if you have here some code that you copied from the other one, yeah, what happens then if you maintain it? Yeah, you need to fix bugs in both of them. What happens if a third person comes in? This person says, I don't understand this one, neither this one. Let's create something new. And that's something that we don't want in a company. And I think also in the Haskell community, we don't want something like this. So what can we do that we are not creating always new things while not making the other stuff better? So the better way would be, OK, can we improve the first package or the first bunch of libraries and make them better in documentation, in understanding how it works, even probably adding examples, so that everyone is using one. Nobody wants to copy it and to improve it, but just helps to make the first one better. And one thing that we think is important for this is that you're doing cleaning of code. Because if you clean code, people will understand it better. Many people will use it. When many people are using it, you will catch more bugs. Even finding bugs is easier if you clean your code. And therefore, one approach that we are doing in a large scale in our company is we are cleaning our libraries. And when I was asked to use these libraries, my job was to clean them. So I was asked to use them, but at the same time, OK, if you don't understand it, it needs to be improved. And so my job was at the same time creating a new game, but also to understand how can we clean these packages that we already have. And how we are doing this. So we focus on different zoom levels. So we start with definitions, with functions. Then we're going to the whole module, taking a look at the whole model. Then across modules, which sometimes makes sense, probably also in your packages. And what is cool in our case, because we are creating games, we can go across libraries and across applications, because we have two games, and we probably can make them the same, and using the same structure. And then it's also easier to get easier maintainability. And this is what I want to show you today. So the focus of this talk is thinking about what we are doing while we are cleaning code, and to discuss what methods we know, but maybe what is also missing, what you can use, what you probably already do, and we don't know about it, and maybe to figure out what is the next step to get better packages, easier to understand packages that are easier to understand, packages that are easier to maintain. So I hope that we get into a discussion to figure out what we can do to improve packages. So let's start with the first one, definitions, something like functions. You all know this, and we're all doing it every day. Let's do the following. I have this code, and I want you to tell me what happens if you compile it and run it. What will happen? Any idea? 15? Okay. Any other idea? 15 is close. But no. No instance for some strange function that we have here. We can't show it. What happened? We have an implicit argument in there. So if you take here, as someone already thought about it, this will give us 15. Because if you take here, the first argument is I. It's never used in the whole function. We have here f prime, which gets an f, which is this function, which has a new I. And then we are summing it after an fmap of the function, and an fmap needs something else, which is a list. And here we have an implicit argument, which is this list, getting in here. If you didn't understand it, no problem at all. This is horrible code. This is code that you can't read, that is really hard to understand. But that's not an exaggeration. That's something that we are seeing in our code bases and also in other code bases that we're taking a look at. So this would give us 15, but it's pretty hard to understand. One thing that we can do to figure out that this is not happening, we can use GSC warnings. Easy thing to do. Just use GSC warnings. How can you do it? Taking a look at the Kaba file, you can add GSC options, W all, W everything, whatever. There are different ways to do it and what you like, which warnings you want to see. But it's good to have them on and to take a look at this. And then we need to compile again. And what happens here? Nothing. You don't see the warnings. Anyone an idea why we don't see warnings here? What I would need to do is something like touch and a minus J1. Anyone an idea what Kaba minus J1 is doing?
Use one core?
Right, use one core. In older Kaba versions, nowadays I think it's changing, so the default will be one core. Older Kaba version is using all your cores. And then you don't see your warnings. And the touch I added because if you don't change a module, it's not recompiled, and then you don't see a warning for this reason. Now we're seeing warnings, many of them. And you can discuss which one you really want to fix, whether you agree on, but I think it's a good idea that you at least handle them and say, okay, I want to handle this one, this one, this one. You can suppress warnings, but if you do this, you're doing it and you state that you don't want to see them. And then everyone knows, okay, you don't care about them, but at least you said, okay, I don't want to see them. And when you go through and add new code, you will see only your warnings that you created, and then you can fix them. And several of them are cool. Probably you're not agreeing on all of them and whether you want to handle all of them. Some people really like name shadowing. I think it's crazy. Sometimes it makes sense. But yeah, so the I that we didn't use, it's just confusing. But sometimes probably it makes sense. Depends on what you're writing. So at least handle them. Take a look at them. And last time I needed to download some packages from HaskellX, and I got so many warnings that I was just, wow, what's going on here? I can't figure out what's going on in my code if I get all the warnings from other packages. So on the definition level, we saw several. So I talked about GSC warnings, but there's more going on, which I think most of the people know about it. We have an idea what's going on here. So use a style guide. Choose one and use it. Just decide for one and go for it. It makes life easier because then your code is just cleaner, easier to understand. It's always the same. It helps everyone. Alignment is a really cool thing for us. We are having often do notation for stream functional programming. And there it helps a lot if you see what are the inputs, what are the input arguments. And if you align all the arrows at the same level, you sometimes even see a bug just jumping in your eyes because it's the wrong input that you get there. It's an argument that is not matching there because you forgot something. So alignment is pretty easy to do. And it helps a lot to understand what's going on in your code. Documentation, we all know it. Yeah, it's hard to do it, but it helps a lot. Naming of variables and functions. We often start with huge function names. And they're horrible, but it bugs us so much that we will figure out what is a better name. And over time, we're creating better names for it. Signatures is something in Haskell that is really important. You saw you didn't have the signature for the example that I showed you, and then you don't know which arguments are getting in there. Just put signatures there. It helps you to understand what's going on. The level of abstraction is something many times is hard to see for the beginning, but it's really important. For example, for a game, you have input sensing. Then you do something with your input, so creating a new game state, and then you render it. And if I have a main function, I just want these 3 functions in there. If I start to describe how the pixel 1.1 is to be rendered in the same function, then I mixed the abstraction. And many times it's the case that if you have a huge function, a large function, that you probably mixed some levels. And there it's always a good idea to take a look. But even a small function could have different parts in there which you probably don't want to have at the same level. So sometimes it makes sense to split them. And we are using HLand. But I think there are many other methods out there. This is just the main that we are normally using. So now we had a quick look on definitions. Let's go on one step out. So taking a look at the whole module. And there I want to make a stand on explicit imports. Same thing as before. Yeah, implicit, I'm not really a fan of implicit stuff. That's the same function that we saw before, but now with fancy names, function names. And if I want to know where magic is coming from, I need to search in 3 modules or 3 packages, depending where they are coming from, where this function is coming from. I don't want to search. I can't search. I really want to focus on the function that I'm writing here. I don't have the capacity in my mind to know where all the stuff comes. Especially if you're getting into a new module that you never have seen before. You don't know anything about the imports. And it's easier if you have them just explicit. But that's not the only reason. Let's take a look at these 2 modules. This is the game state finished. And we have a device output, which is doing the rendering, and a module which is doing the logic, which is, yeah, you change in the game state. And I will show you now 2 blocks of imports. And I want you to match which one works with which module. That's the first import block. And that's the second. Which one matches which module?
Second matches the device output.
The second matches the device output. Yeah, makes sense, because there's a lot of rendering in there. So let's take a look. So only from the imports, I know what's going on in this module. And that's one of the things that I'm normally doing when I start to take a look at a new module. I take a look at the imports and check, OK, what is this doing? What functions are here? And it helps you to understand what's going on. So this is easy to understand if you see it. But what you also have here, in this one, I think there's something wrong. anyone sees something that you probably say, yeah, this shouldn't be there? Okay, we have a question. Right, there is a render environment in there. Why is there a render environment in there? That's logic. I don't want to be rendering in there. I see stuff like this only because I take a look at all of the imports. And then you see, okay, this module is doing something that probably shouldn't do it. In this case, we cannot get rid of it right now, but we're working on it because some of the logic and where something was clicked needs to know where the rendering environment gets information from the rendering environment. But we're working on this and try to get rid of it right now. But we only can see that there is something wrong, and we need to work on it, and we need to investigate on it because we take a look at this. So that's the reason why I really like explicit imports. For the whole module, we have more methods. So one is renaming. If you have 3 functions, they're all related to each other. It makes sense that they have similar names. Putting them next to each other, restructuring, knowing where they are. Restructuring also in the sense of which arguments comes first. If I always have argument 1, argument 2, and then in the 3rd function I just switch them around, then I need to think about which order is the right one. If I always have the same order, then I know it and I don't have to think about it. And I don't want to think. I want to focus on the stuff that I have in front of me. I don't really want to think about these tiny, tiny details which just mess with my mind. We are using HaskellX documentation to take a look at the whole module, and I will show how we are doing it in the next step. So now we took a look at one whole module, but we can also take a look across modules. So that's the case. Why can we take a look at across modules? Because we have a cool structure, which we only created while we were cleaning. Beforehand, we didn't have the structure. What's cool about it? We have a logic and an output, which is, logic we talked about. The device output is the rendering part. And there's some sensing, which we just leave out for a moment. And then we are going to the application. So the whole application gets started. And the logic here knows, OK, in which status are we? Menu status or game status? And it just says, OK, if you're in a menu status, you have to handle it. I don't want to know how you do it. You do it. So we're going down here. And then we could say, OK, the menu knows we are right now in the main menu status, so we're going down here. And then here stuff happens. You click on a button. And then the main menu says, OK, I know how to handle this. For example, preferences, so sound on, sound off. Probably the main menu knows how to handle this. If it does not know how to handle it, because you clicked on the levels menu button, then you go up. And main menu, so the whole menu knows, OK, if I click on the levels menu button, then I need to go here. If it does not know how to handle it, because, for example, you clicked on quit, then it just says, I don't know how to handle it, go here. And what you see here is these are all dispatcher. They're just saying, OK, I get an info, something happens, I need to know where to go next. So these 3 parts are the same. They're using the same function, and they just get different inputs. Where to go? I'm getting this information, then I have to go there. And these down here are also doing the same. So you have to render something, and it's basically always the same. And therefore, we could create such a cool structure, and I wonder whether you have in your projects something like this as well, something like a similar structure or something where you think that there is repeated code in there. Just think a second about it. If you think that there is something like this in there, but you're not sure yet, maybe you want to take a look at a HaskellX documentation. What we will take a look right now is the game loading state. It's the rendering of all of them. Then the game finished state. menu's main state and the level selection screen from the menu. And what we are doing here is we have all the functions here. And how do we do this? So how do we get them the same? So we're switching from one to the other. Do you see the differences? They are minimal. So what is the difference? You have a different name, so the rendering of the level loading state or the finished game state. So that's just the documentation text difference. And there's a precondition down there, which is different. And we are forcing the structure. So we try to have always the same function names, the same arguments, inputs. And we are not only doing this for the game state, but also in the menu state. So here you see a little bit more of jumping. Mainly it's we have a game state or a menu state here. So this one is a one-time game state, one-time menu state. There's one more function in there. And there's something weird here. Here we have int. And here we have a widget pos. This is something I don't want to be there. So this is something I didn't clean right. I need to go there again. I want it to be the same. In the end, widget pos is just an int, so it's the same, but I really want to be sure that it's the same, and I don't want to think about it. It needs to be the same thing. And that's what we are doing when we are cleaning. So here it's the same. They are all the same.
Does it not create problems when you jump to the definition of a given function and you have a million functions named render, for example?
Right. So the question is whether it's sometimes confusing or a problem if all the functions have the same name. Yeah, I sometimes get lost. Because we also have this in different games, and sometimes I really don't know in which game I am. But sometimes it's better to have it like this, because sometimes you don't need to know where you are. So sometimes it's good. And the functions are the same. So we are right now thinking, OK, how can we get rid of them as their own function, whether we can use templates or how to make them even more the same. But this is a minimal step in between to see what's going on there. So it's probably not the end state of the game. Okay, there were many, many questions. OK.
I mean, isn't this actually a little bit weird? Wouldn't a good Haskeller go in and do a type class?
Right.
To actually enforce that structure?
So the question is whether a good Haskell would use a type class. Yes. But we are not yet there. So we are not always having the same structure, and we're in between cleaning right now. And in between, you don't know whether they're all the same. And during this process, we are using this. But yes, we really want to come up with a type class in the end. Same question?
Is this something you would use a local Google instance to search for a certain type signature, and then Google search your code for you and finds several methods with the same signatures?
OK.
Instead of going through the tabs manually.
OK, so the question is whether we could use Google to figure out where we have the same signature. That's a really cool idea. We never thought about it, but maybe yes. Maybe it's a really good thing to try it out with this. So thanks for the idea. So right now we are doing it with Haddock, and it helps us to also get the same structure, because most of the time it's, OK, the first part is the same, and down here there are some auxiliary functions that are different in all parts. And the complete widget collage is different for each module, because you're showing different things. So here something happens, and you need to know how can we make it similar, how we can get the same things, can we use arguments to get just the right same function that we are using. More questions? Good. So, OK. Here, we're taking a look at the logic of the same modules, so game loading, game finished, menus main, and menus levels. And you see what happens if they are not the same. So I know the functions are the same. I know it because I wrote them. That's horrible. You can't see anything. Because the function names are different, then you don't see whether the signatures are the same. and everything is just jumping around. So that's what we try to get rid of. But when you start, you don't have the structure, and you didn't know how to do it right. So you need to come back and figure it out how to do it right. Okay. Another method that we are using while we are doing this is v minus d. So to diff two modules. The image that will come up now is horrible. If you see v minus d the first time in your life, you get killed by many, many, many colors. I will help you to go through it. Yes. The first year I was really, really confused by it. Nowadays I just see, okay, that's nice, easy, understand. So what you see here at the beginning, there is one line more on this side, which is not there. Good. Here, the difference is this is called loading, while this is called finished. Okay, that's the only difference. Okay, my module has a different name. Can live with this. Here we have different imports due to the fact that this function is different. And here, yeah, this is still imports. But this part, the complete part here, the black part, that's the same. Cool. We have duplicated code, but what can we do? But for these parts are we searching for, and we even try to align stuff in the same way that we get these parts or see minimal differences. Something like, okay, the name is different. So what we are doing for across modules is also renaming of functions, restructuring in the whole module, but also what is in which module. Because sometimes you have a function that just should be in another module. We're using head documentation, v minus d. Diff-rq is something I will show in the next step. We try to make it abstract when we can, but yeah, it's an iterative step by step, you have to go through it. We are using shared modules and libraries. And sometimes if we are not sure whether we will need something in another game, we're just having something like library extra. And then we think, okay, probably this is something that we can get out. One thing that probably I can explain here better is we're using external imports and internal imports. If some function only uses external imports, then it's something like a candidate for going into a library and into our game libraries, because then it's nothing needed from within our game. And then this is something we probably can get rid of, and if we're using it also in other games, then it just goes there. And let me see. This is for external imports. Sometimes you have some internal imports and you can't get rid of it. Yeah, too bad. You try to get this more abstract, and then, yeah, you try to get it more abstract, but sometimes it's not possible. So what we are doing sometimes is have a shared module within our application, and we're just saying, okay, everyone is using this one, but we can't get rid because the game state is something that we need to define in our game itself. We can't get rid of it. We can try to make it more abstract. Sometimes it works, sometimes it's not working. Something interesting in here is that the complete visual that we have here is the function down here. It looks like these functions are the same, but they're calling a different function. So what you could do is getting this complete visual, so this function as an argument, then it's all, again, the same function. But as long as it's down here, it's a different function over here. These two display, they look the same, but they're not really the same. So type classes could help us to get there. Okay. And therefore, we try to get stuff in the libraries. If it's not possible, we're thinking right now of templates, because in our games, we always have the same structure, and sometimes it makes sense. Okay, we have a device output here. This is one module for the main menu, for the levels menu, and we always have a logic in the device output there. And it will be always the same. So there we're thinking about templates. Okay, so now we took a look at across modules. And since we create games, and we hope to have all the same structure in all of our games, which helps us to maintain them easily, we take a look across libraries and applications. So here, again, head-hoc documentation. This is the M-Puzzle. This is the first game that I created. This is another game which is not yet completely created. Do you see differences? Right, there is no main in the left one. Other one? More.
Sage.
Right, there's a Sage extra somewhere over here. Okay. I don't want these differences. So the next step would be, here we have an app main, and here we have a main. I needed to rename it due to the fact that Android and iOS didn't like that I used the word main as module, so I needed to rename it. Next step, rename it here as well. It should be the same. If I have to do something like bug fixing, I prefer to write a script saying, okay, in every app main that I have, just change this line. And you can do it if they have the same name. So next step would be getting here the right name. Then we have here Sage, Sage Extra. This is nowadays called Fawn, is our game library that we are using. And this game has just more information. This is the one. Probably there is something in there that might be used also in this one someday. But so far it's only used in this game, so we have it here as an extra library. But we try to make them the same as much as possible. Okay, and next one for the V-D. We do this also about in different games. So this is the main menu, device output from N-Puzzled, and here it's the escape. The difference here are easier to see. So everything that is the same is folded. So we have many, many lines here folded. And what we really see is here the background. We have here a background image. This game does not have a background image. Yeah, the graphic designer haven't seen this game yet, so we don't have a background image yet. Good. This will change probably. And then probably it's even the same because we are using some IDs for it. And if we're naming all the same, then we have even there a similarity. And here, my designer told me a few days ago, yeah, please align them a little bit different. So I changed here the number, and here I didn't change it yet. Probably the device output will be different in the end, but the question is how much it will be different. And we try to make it at least different as possible. Okay, this is the logic. No difference at all. If there's a bug in one of them, I just fix it, and I can copy paste or even just copy the module into the other game, and then it's fixed. That's where we want to go. Okay, here we have the structure of one of our games. This is M-Puzzled, and it's the menu structure. So we have a main menu, device output, constants, and logic, levels menu, about menu. And here, this is the part of the dispatcher. What we are doing is we are using diff-rq. And with diff-rq, this is unfortunately with this browser a little bit different. But what we are seeing is this file is different, this, and this. There are not all the files in there. We saw that the logics are the same, so it's not showing up here. And what we are doing is we're going through this list and think, does it need to be different? Can we make it the same? So here we know what is the different. This is the background image that is missing in one and not in the other. And then we're thinking, okay, can it be the same? Can it be the same? For example, this one bugs me a lot. It's a state. Menu state should be the same. I really want it to be the same. Why is it different right now? We have in M-Puzzled, the first game, we have statistics that you need to see was a level played already. This is in the first game, we have it. In the other game, we don't have it yet. We think probably it will come there anyway. So my next step would be saying, can we put here a dummy? Just to have the same structure. And during the time, we will see whether this dummy is used. If in many games we're using it, then OK, we will have it there. Or if we see it's really only one game that needs this structure, this will be the exception. But we try to get exceptions as minimal as possible, because this is something you have to think about, and I don't want to think about it. Okay, across applications, we are doing, again, renaming, restructuring, header documentation v-d, diffrq. We try to make it as abstract as possible. We're using libraries and templates. So basically the same ideas that we are also using for across modules. So now you have many, many methods. But this is just too much. How do I start? What do I do? So the whole thing is iterative. You have to go there, you need to come back, and you need to take the time. Sometimes we are sitting there for 2 months just cleaning, trying to figure out how to do it right. But it needs time, and you need to do it step by step. Sometimes you say, OK, now I'm done for this week. Let's go back in 2 months. Just see, does it work, that what we have cleaned? Or probably it does not work, then you need to go back. So iterative, step by step, starting with tiny, tiny stuff. Alignment, already cool. Having a good alignment helps already. 5 minutes done, good. Discuss your code with other people. So asking your friends what they are thinking about it. Can they work with it? Do they understand what's going on? Probably they can even help you to clean your code. So they're going through it, and they will mess it up at all. You will afterwards, it could happen that your functions are in different modules, and you don't think they don't belong there. But then you know something is wrong. Either this person does not understand it, or you don't understand it, but something is wrong here. So you need to figure out how to do it that everyone has more or less the same idea about it. They probably make some stuff more abstract, and then it's cool. But they're probably also giving you some warnings, name shadowing, and then you need to figure it out again. Or just document their code because they just made it cool, but they didn't do the whole thing. So that you have, again, missing signatures, missing documentation, or just function names that are so horrible that you don't understand what's going on there. So sometimes it really makes sense that other people also cleaning your code. So to sum up, what do you think, when is it worth to clean? So in my case, I think it's worth to clean in the moment that I have to maintain the code or others want to take a look at my code. If I'm writing a prototype, yeah, I'm not cleaning. I won't just want to know whether this feature is working. And the moment that I know, OK, it's working, this code will be thrown away in 1 week, 2 weeks. So I don't clean. But the moment that I need to work with my code longer than 2 months, 3 months, I want it to be clean. How much effort is it? That depends. You never know. So some stuff can be done pretty easy and pretty quickly. But sometimes we restructured our games 2 or 3 times to figure out which is the right structure. And you need time to do it. But we think it's worth it, because now we can do stuff that we couldn't do beforehand. And it takes time, but we think that in the end, maintainability will get easier. And especially if we don't have only 2 or 3 games, but 5, 10, 20, even 50 games. So then we really need a good base to work with it. What methods can you apply? You saw many of them. I hope there are out more that we don't know and we're not using, and I hope we can talk about this. So whether we can find better things, or maybe we need better tools. For example, to get the imports in our games or in our modules right. If there is a tool that just gives us all the imports, this would be so cool. So that I don't need to do it manually, because manually it's sometimes really hard to get in touch with it and stay with them. So this would be cool if we would have a tool there. And as a last question, no, that's not the last question. So how can you convince others that cleaning is cool? I really would like to show you something like before, after. And then telling you, OK, therefore it's cool. And I tried this. When I started this talk, I thought, yeah, I really want to do this. So starting with this, and we're getting there. And then I figured out, if I really want to show it, it's just too huge. When you try to see that there's really an effort in there and that it really makes a difference, then it's only working on bigger projects. And I can't do this in 40 minutes to show you, okay. And therefore, I guess you need to take a look on your own and see whether it works for you and how it works for you. And then, yeah, if you see it, probably you can convince others to do it as well. And now the last question, and this is the one that I leave you with. What is more fun than working with clean code? So thank you very much.
Thanks, Christina. We've probably got time for like one very quick question if anyone's got one. You were quickest off the mark.
Yeah, it was just thanks for the presentation. So when did you start working on games in Haskell? Have you done it mostly on your own, or were you part of bigger teams at some point? Or because that's cool. I've looked into game development a while ago and was trying to fit FRP through that, and it was like really a mess, complicated stuff to figure out. So.
Okay.
Yeah.
So Kira is pretty old, I think, already, because Ivan Perez, he is Ivan Perez Dominguez. He is the owner, my boss in the end, and he started this startup company. I don't know how long it is. So he created games a long time ago. I think it's at least 5, 6, 7, 8 years ago. I don't know. I came there 2 years ago, so I got into the company, but the company already existed. The first game was already out, so Magic Cookies, which you can see here, is in the App Store and in iOS and Google App Store. And yeah, so he figured out how to do it. He was writing his PhD related to it. He is using, or we are using now, FRP Yampa. And right now we are going to Dunai, which is monadic stream functioning, which has Yampa inside it. And there we hope that it's getting easier to do animations right, because this game has animation, but my game doesn't have animation. And all the testers are wanting animations, so we need to get the animations in there.
Cool. If any of you have got further questions for Christina, I'm sure she'll be around for a little bit, but let's just thank her again, and that's the end of the session. Thank you.
Thank you.